So we're very excited to introduce the Desktop Metal Studio Plus system, the very first printer from Desktop Metal in the country. We'll be using that as our demo printer to talk to customers about applications and how they can use the technology. We can produce benchmark parts as part of our sales process. We're also going to run this machine through our bureau service, where we will offer manufacturing services for metal parts as well. To the right is the Studio Plus 3D printer, one part of the equation. So a more typical FDM extrusion-based process using polymer binder and metal powder. From there, we take parts and put them into the debinder bath. From the debinder bath, when we soak the parts to remove the binder, we then transfer parts into the furnace, where the parts are sintered at up to 1,400 degrees Celsius. The entire process has been designed by Desktop Metal, which is very unique for this bound metal deposition process. The thought process behind that is that we can control all parts of the process. We can 3D print our parts, control the debinding and furnace in a much more economical time frame and produce much more dense parts and stronger parts to give us better output at the end of the equation as well. All this hardware is controlled by one piece of software, Desktop Metal Fabricate. And the uniqueness about the software is that it programs not only the 3D printer to print your parts, but it also programs the debinder and how much time it will take to debind your components, as well as programming the furnace. Parts of different shapes and sizes and materials will require their own unique furnace profiles, sintering profiles. And rather than us having to be metal experts and metallurgy experts, we can rely on the software to produce a sintering profile for us. And that is extremely unique to Desktop Metal and a complete solution that I believe is the only one in the world at this point in time. So I'd like to touch on some of the pieces of equipment in the package. The Desktop Metal Studio printer is a typical FDM extrusion-based printer with a unique difference that rather than using filament, we use some metal rods. And anyone familiar with the metal injection molding process, the process uses a polymer binder mixed with metal flakes. What Desktop Metal have done on the Studio system is made that into rod form. We have model material and we have support material. So in this case, we have 17-4 stainless in rod form, and we have our ceramic support structure that gets used during the furnace profile to make our support structures very easy to remove. The way the system works is we'll take some material. Those rods are held within a cartridge, and all those rods are within this material cartridge. It takes less than a minute to load this and the support structure into the 3D printer. And in that regard, we're able to change materials from 17-4 stainless to 316L to 4140 to ceramic in less than a minute. So very, very different to a lot of systems that are out there. Very versatile system to enable that. Inside the machine, like most FDM printers, we have a build tray and extrusion heads, one for model and support. Typically, the part you will get out of the 3D printer is what we refer to as a green part. You'll see that there's the component itself, there's a white layer, which is our ceramic media, and it's built on a base. What we do with this part is then take that to the debinding bath. So as part of the process in changing materials, we not only remove the cartridge at the top, but with the cartridge we also remove the print heads, and Desktop Metal have designed a quick release print head system that makes the print heads very easy to remove. So you keep this print head running stainless steel 17-4 with the cartridge and swap that over for another material. So once the part has come off the printer, we put the part into the debinder bath, again developed by Desktop Metal, and we'll have a look at the way we remove the parts. The system is fully enclosed and sealed, so undoing the toggle clamps and opening the lid allows us to get access to the parts. The unique thing about this debinder bath is that the solvent that gets used in the process gets drawn away from the tray that I'm about to remove, so that when you remove a part, the components are dry. They can be touched with the hand. There's no need for gloves. There's no toxic fumes. We don't need extraction on this device because all the solvent gets stored away and any waste gets stored into a chamber at the bottom for easy disposal. So there's no cleaning of the system required as well. To remove the components from the bath, it's just on a tray. And the parts that come out of the debinder bath are then classified as a brown part, which we can then send to the furnace. So the final piece of the puzzle with regard to the hardware, and probably the most important piece of hardware in the setup, is the Desktop Metal furnace. So this is where all the development has gone in from Desktop Metal, and a lot of the intelligence from the software automatically programming the furnace to sinter each part with its own unique sintering profile. The software will tell you not only what sintering profile, but where to place the parts in the furnace to get the best results and to get maximum density and strength out of your parts. The furnace is very, very unique. It works under a partial vacuum, which allows us to use much less gas. It also has a very large chamber, box type chamber, that allows us to fit a lot more parts in compared to a conventional tube furnace, which can only put a very limited number of small parts in. So the Desktop Metal furnace allows you to put more components in. So during a cycle run of 24 to 48 hours, you're getting better return on investment by putting more parts in the furnace at one time. The other unique aspect of this furnace is because it does work under partial vacuum, that it uses a lot less gas than a typical tube furnace as well. So a typical tube furnace may use 8,000 litres of gas, as opposed to this machine using 800 litres of gas in a 24 to 48 hour cycle. So the return on investment and the economy of operating this piece of equipment is far superior to what else is out there on the market today. From the outside of the furnace to the inside of the furnace, you can see the area within the furnace build chamber being a box furnace. This is a graphite retort box that gets used to stack components within the chamber of the furnace. So the software from the Studio system will not only tell us which parts that can be furnaced together at the same time, but whereabouts we should stack these components within the retort box, again, to give us the best mechanical properties that we can when sintering our parts. Multiple layers means we can stack these parts in any orientation, and there's also channels and chambers that control airflow to maintain constant temperature throughout the furnace. Again, something very unique to a box type furnace as opposed to a tube furnace where you can get temperature variations from one end to the other. So as part of the Desktop Metal process of debinding and sintering, once the part comes off the printer, you can see it has its model material, some white ceramic support structure, and the base that it builds on. Once we take that out of the debinder bath and put it into the furnace, the part gets sintered. What that allows us to do is then twist the part, remove it from its base, because the ceramic support layer has turned to ash during the furnace process. What you'll also notice here is the variation in size. So typically with this type of furnace process, you'll get around about 19% shrinkage on your part. There's no need to worry about it as a designer or an engineer, because whatever you design, the 3D printer scales the model up 19% to what it needs to be, and once we furnace, you end up with the finished part at the accurate size that you started with in your design. This is a component that has been furnaced and finished, so fully dense, stronger than a cast part, whether that's investment cast or sand cast. The density is about 96 to 97% dense in 17.4 stainless or even 316L. You can also see that this part has been finished machined as well. So like any metal component, you're able to finish machine on the outside surfaces, the inside. There's no pitting, there's no voids. It is a fully dense functional part that can be used for production applications.